Okay, so today we are talking about our Wi-Fi 6E access points. I guess to back up a little bit here, let me introduce myself. I'm Sean Rogers. I've been with Zyxel since 2003, and I head up our wireless products here in North America. As we go through the presentation today, feel free to ask questions. Send those in using the question and answer interface, and I will try my best to answer those as we go through. In some cases, though, we may need to wait till the end of the presentation before I can answer the questions. So we'll start off talking a little bit about Wi-Fi 6E. You've probably heard about it. So Wi-Fi 6E is just Wi-Fi 6, but extended into a new segment of RF spectrum that's been made available here in North America and several other countries. So it gives us approximately double the capacity as far as RF spectrum compared to 5 gigahertz and 2.4 gigahertz combined. So it's opening up a lot of space here for us to use. It gives us the ability to have simultaneously 7 non-overlapping 160 gigahertz channels. And this is a space that, at least when it comes to indoor usage, hasn't really been used by anything else before. So basically the only products that are going to be using this spectrum are other Wi-Fi 6E products. You don't have to worry about competing for RF time or airtime with other wireless devices. So we'll take a look here. This is just showing you here, sort of mapping out, the 2.4 gigahertz spectrum doesn't give us a lot of space. It only gives us a little bit around 60 megahertz of frequency. 5 gigahertz opened up a lot more, somewhere in the neighborhood. I believe it's around 600 megahertz of frequency. So in 2.4, you had you had 3 non-overlapping 20 megahertz channels. In 5 gigahertz, you have somewhere around 24, 26 non-overlapping 20 megahertz channels. And some of the problems we run into, though, is that as we've increased, Wi-Fi speeds, as we've gone from B to G to N to AC and now to 6, is a big reason that we get these faster speeds is we allow access points and other wireless devices to use larger chunks of spectrum. So you can see here, starting with 11 AC Wave 2 and now Wi-Fi 6, those fastest speeds you see are using 160 megahertz channels. So obviously you can't do that on 2.4. There's 60 available for everyone to share. On 5 gigahertz, you've got 2 channels that you can use that don't interfere with each other. The challenge we run into here is something called DFS. So in order to use these wider channels, you need to use DFS. And if you've sat through one of my Wi-Fi 101 webinars, you know that with DFS, there are other legacy devices, including radar, that are using those frequencies. And so you may periodically be kicked off for short periods of time due to the AP detecting a legacy device on that same channel or thinking it detects a legacy device on that channel. In addition, a lot of consumer products don't support DFS channels. So a lot of consumer equipment, if you're allowing people to bring their own device, may not be compatible if you're using those DFS channels. So if you don't want to use DFS, you've got to drop down into slower 80 megahertz channels. And you're essentially having your speed at that point. But with Wi-Fi 6, you've got 7 of these 160 gigahertz channels that don't overlap. So it's going to allow you to use the full speed potential of your access points and of your wireless devices when using 6 gigahertz. So what is the application for 6E? And it really comes down to 2 main things that you're looking at: high density environments. If you have a lot of users or the need for a lot of access points in the same area, 6 gigahertz channels are going to be something for you to take a look into. And then also, because it's so easy to be able to maximize your speed and not have to, reduce speeds in order to deal with interference issues and channel availability issues, it's ideal for very high bandwidth applications. Streaming virtual reality is one that should benefit from this. 8K streaming, things like that. So in the business side of things, at least at first here, you're not going to be covering your entire office with 6 gigahertz access points. You're primarily going to be using this in areas where, again, where you have a lot of users or a lot of devices in the same area. So conference rooms, meeting rooms, expo centers, possibly large warehouses. Sometimes in large warehouses, ones that are full of a lot of non-RF conducting materials, you maybe have to put in a lot of access points. So that would be another area. And then if you're dealing with, an office building where you've got a lot of smaller tenants, 6 gigahertz might be nice also, because you have to worry about interference issues from your neighbors when it comes to using 2.4 and 5 gigahertz. So 6 gigahertz may be beneficial for you there. And then schools is going to be another big, I think, key player for 6E, and probably going to be one of the first industries that really pushes for 6E products. And that's just because, again, you've got a lot of students crammed into a room, and you've got rooms right next to each other. So you quickly end up exceeding the available spectrum that's there for 2.4 and 5 gigahertz users. So 6E, using that 6 gigahertz spectrum, is going to be a big benefit there for you. So what are the trade-offs here? We should talk a little bit about that, especially when we're dealing with business stuff. Again, if you've been through our Wi-Fi 101, you know, as frequency goes up, range goes down. The signal does not carry as far. So that's why 5 gigahertz doesn't have the same coverage as a 2.4 gigahertz. So 6 gigahertz will have even lower coverage than 5 gigahertz. So, I mean, again, and that can be a benefit if you're in a high density environment, again, such as a bunch of small offices in a large office building. Condos and apartment users may also benefit from this, right? So there's going to be more bandwidth available to share with your neighbors, so you aren't stepping on each other's toes. And because it's 6 gigahertz, it doesn't travel as far, so you aren't getting interference from neighbors all the way down the hall or on the other side of the building, like you may be getting with 2.4 or 5 gigahertz in those scenarios. And then, of course, the other big challenge is, in order to use Wi-Fi 6E, not only do you have to have a Wi-Fi 6E access point or router, but your client devices need to be able to support and work on that 6 gigahertz spectrum. And as it sits right now, there's not a lot of devices that do it. Some flagship cell phones have it. Some flagship laptops, like gaming laptops, may have it. But it's going to be a while before it becomes ubiquitous. It's going to become a while before it becomes cheap enough that it's something that you find in a lot of consumer-aimed devices. So that's something that you're going to have to keep in mind, that it's going to be a while before everybody can use 6 gigahertz. So in the business environment, another good case for 6E is doing wireless backhaul. We support mesh on our access points, but we generally don't recommend it, just because in a business scenario, you've got a lot of access points. There's not a lot of 5 gigahertz spectrum available. So you end up crowding things. So with 6 gigahertz, you can now use 6 gigahertz for your mesh backhaul between APs to create that mesh. And it's fast, it's not prone to interference. And because there's so much spectrum available, you don't have to worry about it stepping on the same frequencies that you're using to be able to talk to your client devices. Okay, so that's it for talking a little bit about the technology. Probably could have done a little bit better. So let's talk a little bit about the products. Now, the first thing I'm going to tell you here, and this is very key, and I didn't start out with it because we always get some stragglers, but we did a global launch of our Wi-Fi 6E products last month in June. Announcements went out. You probably heard about them. We scheduled this webinar. Unfortunately, here in North America, our Wi-Fi 6E products have been delayed. Due to FCC requirements, we don't use the same exact hardware in the US as we do in other regions. We require some different components that are exclusive just for the North American market. And unfortunately, as you probably are aware, there's a lot of silicon issues and shortages in the computer industry right now. And unfortunately, the components we need for our Wi-Fi 6E products, we thought we were going to get them delivered to us, and unfortunately it was delayed, and we still don't have a firm timeline of when these will be available in North America. Most of our distributors, though, should have these set up, and so you should be able to place orders now for drop ship, and then once the product does become available, you'll be one of the first to get your hands on them. So sorry about the bad news there. So now we'll start talking about the products. The first product, and this is going to be our entry-level Wi-Fi 6E product, is the NWA220AX-6E. So similar to our NWA210, this is classed as an AXE 5400 product. So roughly 5.4 gigabits per second wireless throughput in theory on this device. Now, this is a dual radio device. One radio is dedicated to using 2.4. The other radio can either be 5 gigahertz or 6 gigahertz. You cannot use them both at the same time. And the idea behind this is 1A, to reduce cost. So, obviously, if we're putting 3 radios in there, you've got to pay for the extra radio, you've got to pay for an extra set of antennas, and you've got to pay for a higher power more horsepower in your CPU to be able to handle the throughput of 3 radios simultaneously and juggle all of that. So it saves you a little bit of money. And the idea behind this is largely that, as I mentioned, not a lot of demand for 6 gigahertz right now, not a lot of client devices that currently support it. So this way you can buy a Wi-Fi 6E access point today, deploy them at your customer using 5 gigahertz. And when that time comes around where 6 gigahertz client devices are cheap and ubiquitous, you can simply flip a switch in the software and turn it over to 6 gigahertz operating mode. So it operates either way. The 2.4 radio is 2x2, so 2 spatial streams in both directions. The 5/6 gigahertz radio is 4x4 in either mode, so 4 spatial streams in either direction. This access point is Nebula Flex, so you can either manage it directly or you can use the free Nebula Cloud to manage the access point for you. Showing the underside here, you will see it has a 2.5 gig uplink port that supports PoE. And it has one pass-through port, not PoE pass-through, just a data pass-through port. And if you don't want to do PoE for some reason, such as using it in a mesh scenario, it can be powered with a AC adapter. Now, I do want to highlight here, it only requires 802.3 AT PoE. So basically, any of our switches that end in HP will be able to fully power this access point. The next step up from here is the WAX620D-6E. So very similar to what we were just looking at here with the NWA220. It is an AXE 5400 class product. It is dual radio, 2x2 on the 2.4, 4x4 on the 5/6 gigahertz radio. So this one is a Nebula Flex Pro device. So this can be managed directly. You can use the free Nebula Cloud, and it also includes bundled with it 1-year license towards our Pro Pack, which unlocks additional features in the Nebula interface. Or it can be managed with one of our controllers. So you can, if you use a USG or a VPN on the gateway and you want to do local management, you can do that with these through that built-in controller that's on our security products. And then this one also adds our dual optimized antenna technology, giving you 2 different sets of antennas to choose from, one optimized for ceiling mount, one optimized for wall mount. And again, on the bottom, you've got that 2.5 gig uplink port that supports PoE, a 1 gig data pass-through port, and the ability to also use an AC adapter. And then lastly, we have this here. This is the WAX640D-6E. This is not something that has been set up at distribution yet. This one was originally planned to come out a month or 2 after those 2 that we've just talked about. We don't have pricing set on this yet, but it is coming. And with the delays on the first 2, all 3 of these might hit our shores here at about the same time. So this is more of a flagship product. This is a true 3 radio tri-band access point. So you can operate all 3 bands, 2.4, 5 gigahertz, and 6 gigahertz simultaneously. It is an AXE 7800 class product, so roughly 7.8 gigabits per second raw data throughput between wireless devices is possible. The 6 gigahertz radio is 4 spatial streams, 4x4, and then the 5 gigahertz and 2.4 gigahertz radios are 2x2. So now this one also is Nebula Flex Pro. So again, you've got direct management, free cloud management, bundled ProPack license, or can be managed with one of our security gateway devices that have that built-in controller into them. And then this one also adds smart antenna technology. We'll talk briefly about that in a couple slides here in just a moment. And then setup wise, it's basically the same thing as the other two. You've got that 2.5 gig uplink port. It still works just fine using 802.3 AT. It does not require 802.3 BT or PoE++ in order to be able to power this, this device. And then it's got our standard mounting bracket that's been designed using our optional T-bar clips to be able to clip directly onto T-bar for drop ceilings. It's also got a number of different patterns of screw holes to allow you to mount it directly into a round junction box, a US outlet box, or directly into a ceiling or the wall. And these products continue our general design philosophy when it comes to our business class access points of RF first. So it means lots of shielding, antennas not mounted directly to the PCBA, directly separated, no electrolytic capacitors. And the shielding is especially important when it comes to Wi-Fi 6E, because 6 gigahertz and the 5 gigahertz spectrum only have about 50 megahertz gap between the two. So you do get a lot of band edge overlap between the two. So you need that shielding to make sure your 6 gigahertz radio isn't interfering with your 4 gigahertz radio, especially on these tri-radio access points. So for those of you not familiar with dual optimized antennas, that's the antennas that are on that the WAX, the new WAX model there. Basically, your typical AP is designed to be mounted on the ceiling above the area that needs to be covered. However, out there in the real world, sometimes you've got to mount APs on the walls. You don't have ceiling access, or you do, but there's, ductwork and things like that that are going to interfere with RF. So you end up having to mount them on the wall. But unfortunately, when you do that, you're using the antenna coverage pattern is basically at 90 degrees from what it's designed to be able to use. So you don't get good coverage. And if you're near a multi-story building, you may get interference issues between floors, as a lot of that signal is going to go up into the ceiling and down into the floor. With dual optimized, we've got two sets of antennas, one for the ceiling, one for the wall. So you just choose based on where you've deployed that access point, which antenna pattern you want to use to optimize coverage based on how you've done your deployment. And then on the smart antenna side of things, again, we go into this in a lot more in depth in some of our other webinars that we do. But basically, it's a technology that's client agnostic, that's designed to increase capacity, how many users can be connected at the same time, to increase coverage area, to maximize that performance, and to reduce interference. Now, with 6 gigahertz, there shouldn't be a lot of interference issues because 6 gigahertz, at least indoors, is primarily aimed, it doesn't have any other legacy or competing technologies using it, except for maybe some industrial equipment that's putting out RF. So you don't have to really worry about interference. You've got a lot of bandwidth there, so you aren't really worried about overlapping with your neighbors, in theory here. But there are still some benefits for you. So again, just showing these are your typical antenna patterns. The ceiling mount AP is generally a circle. And then you can also have directional APs, primarily used in outdoor point-to-point applications. So I'm going to skip through a little bit of this here, but the main thing with the smart antenna is instead of having, one fixed antenna pattern, or like a dual optimized having two antenna patterns, with smart antenna, you've got hundreds of antenna patterns. And the AP is basically in real time able to choose an antenna pattern based on where the client device is in relationship to that access point. So it's optimizing the signal, focusing that signal towards the client so you get better range, but also because it's tailoring that antenna or the signal pattern, it can ignore interference from other different sources. So with 6 gigahertz, the main benefit here is being able to direct that signal towards that client device, right? Because 6 gigahertz is high frequency, so it means it's got lower range. So smart antenna helps boost that range and get you better performance than you would have without the smart antenna technology. And then just briefly here, I'd mentioned earlier, we support Nebula Flex and Nebula Flex Pro on these access points. For those of you not familiar yet with Nebula, it's a free cloud-based management platform that can manage our access points, our switches, and our security gateways. You don't have to do anything special on the device itself. You simply plug it in, and as long as it has power and an internet connection, it will find out its configuration. It'll automatically update its firmware, and you can remote manage it from anywhere you've got access to a web browser. The free version of Nebula has no limits on the number of customers you can manage or the number of devices you can manage. And then also just wanted to draw your attention here again when using Nebula. We make it really easy to do guest access, including requiring users to log in with a username and password. Unlike some other captive portal solutions out there, it doesn't require anything on your gateway. The captive portal functionality is built entirely into the access points themselves. So you can simply add some of our access points to an existing network. You don't have to change out that gateway, and you have access to captive portal. With Nebula, we have a cloud database for users. So you can use that and don't have to worry about setting up radius and linking that to your access points to control user access, et cetera. And with that, guys, it is the end of today's webinar. I hope it went through all right. You can send in any questions you have. In the meantime here, just wanted to draw your attention to our YouTube site. Most of our webinars are recorded and then posted there. So there's always archives there that you can find of past webinars. And if you missed something today, or you think that today's webinar would be beneficial for one of your colleagues, you can always send them to our YouTube channel. It's youtube.com/Zyxel America channel. There's a lot of different Zyxel channels on YouTube. So Zyxel America channel, all one word. We'll get you to these US webinars that we've done. That's mine, those that are done by Tri, those that are done by Marcus and others. And of course, you can always find us on LinkedIn at Zyxel US channel. But I'll stick around here. If you have any questions, go ahead and send them in with the question and answer interface. One question we've gotten recently a lot has been, outdoor. Are you going to have a 6E outdoor product? And the answer is yes, at some point. But it's kind of out of our hands right now. So the 6 gigahertz spectrum, right, wasn't just sitting there unused. There were legacy users that had been using that for other applications, primarily outdoor applications. So the FCC has created a new technology similar to DFS, but supposed to be more smooth and less prone to dropping connections to deal with this. And unfortunately, the FCC, as far as I'm aware, still has not finalized how that is going to work. So until the FCC finalizes it, you can't sell a Wi-Fi 6E product to be used outdoors. In addition, there are a number of lawsuits from these legacy users against the FCC telling them that, hey, you can't open up 6 gigahertz for outdoor use. We're already using it. So several of those are still trickling through the court systems. So who knows how that's going to also affect things. I'm sure that's at least in part why the FCC rules for outdoor 6E use have been delayed. So it's something to keep an eye on. It is something that will eventually come out once all of the regulatory and legal issues get solved. And I don't have any questions, so I'm going to go ahead and end today's webinar. I appreciate you guys turning out. We will do this one again, hopefully a little bit more polished in the future once we do get those products in. But again, if you're one of our resellers, these should be skewed up at all of our channel distributors. These should allow you to go ahead and place an order for drop ship or future shipment. You may have to argue with your sales guys a bit, but the NWA220 and the WAX620 should both be available currently for pre-order. So those will get shipped out as soon as they become available. But thanks again, guys. I appreciate you turning out.